Fourth lesson on the circles chapter, chapter 6 from the Year 1 Pure textbook. There's 2 examples to do before exercise 6D. So example 8. Example 8 wishes us to find where the straight line meets the circle. So a straight line can meet a circle either at 2 points, where it's a chord, or it can meet it at 1 point, where it's going to be tangent to the radius, or it might not even meet the circle at all. So in this question we've got a straight line, y equals x plus 5, and we've got the circle given by x squared plus y minus 2 squared equals 29. So in order to work out the point or points where it meets, whether the straight line meets the circle, we solve it simultaneously, which is effectively a GCSE question. So we're going to take this value of y, smash it in here, expand, and then form a quadratic and solve. So the first thing to do, if I put it in here, which will give me x squared plus x plus 5, which is y, take away 2 squared equals 29. So expanding that out, x squared plus x plus 3 squared equals 29. X squared plus x squared plus 6x plus 9, which is that bracket expanded. And then tidy that up and bring the 29 over, giving me the quadratic 2x squared plus 6x minus 20 equals 0. Whenever you try to solve a quadratic, check to see if you can simplify the coefficients. They're all even, so clearly can divide them all by 2, giving me x squared plus 3x minus 10 equals 0. So I have 3 methods in which we can solve this. We can first factorise, which should be our go-to method. If you can't factorise it or don't see the solution, then go for the quadratic formula, but you've also got completing the square as a backup method. So if I factorise it, I think it goes, I need to think of 2 numbers that times together to make minus 10 and add together to make 3, and that's going to be plus 5 and minus 2. 5 take 2 is 3, 5 times minus 2 is minus 10. So the solutions are x equals take away 5 and x equals 2. At this point, a very common error is students to leave the question there, but we do have to work out the y coordinates, which is very simple because we've got y is x plus 5, so just need to add 5 to both of these. So y equals 0, y equals 7. It's good practice to give these answers coordinates. There can be no misconception which goes with which. So we've got minus 5, 0, and 2, 7 are the 2 points where the straight line meets a circle. Example 9. It says, show that the line y equals x take away 7 does not meet the circle x plus 2 squared plus y squared equals 33. We're going to start off to show they don't meet by trying to find the points where they meet and proving there's no solution. Exactly the same method as before. The y value is going to plonk in here. So I've got x plus 2 squared plus x take 7 squared, because remember this is y, equals 33. Expand both the brackets, x squared plus 4x plus 4, which is this expanded, plus x squared, take 14x plus 49. Common error there would be to minus 49, so we'll check for that. Equals 33. Okay, tidying that up by simplifying like terms and bringing the 33 over, we get 2x squared plus, actually, minus 10x. And then we've got 53, take away 33 is 20. And I can halve them all, giving me x squared minus 5x plus 10 equals 0. So think of the 2 numbers times together to make times together to make 10, add together to make minus 5. Quickly you'll see you can't do it. So if you go for the quadratic formula, which you do need to memorise, this part here is the discriminant. Now, given that we're told to prove that it doesn't meet the circle, I know the discriminant is going to be negative because we cannot get a real solution to the square root of a negative, meaning there is no solution to this. If you try and whack this into the equation solve in your calculator, it'll give you an error or just give you no solutions. But to prove it, we do need to prove that this is less than 0. That's what I need to show. So, b is -5, a is 1, coefficient of a is 1, c is 10. So that's 25, take away 40, which is -15. But you can't leave it like that. You need to show that you understand the fact it's negative means there's no solution. So you write something like this. Therefore, b squared minus 4ac is less than 0. Therefore, no solutions. Therefore, line does not meet the circle. Just make it crystal clear to the examiner you know what you're talking about. Okay, that's all the examples prior to exercise 6D on page 122. So crack on with those then.